So I'm going to highlight some of the aspects of why you want to choose Azure for your cloud. So Azure is serious, very serious. Just on that note, I know some of our cloud competitors like to be the cool vendor. We're not the cool vendor. We want to make our customers cool. We're the dependable vendor. Yeah? So Azure is serious about a developer productivity. You can choose your own tools, your OS, and your platform from infrastructure as a service all the way through to platform as a service using marketplace deployments or your own custom deployments. And using Azure DevOps, you can implement continuous delivery of your code to any cloud. So Azure, AWS, GCP, or even on-premise if you prefer. You can visualize those deployments to any number of interdependent stages, and you can choose a combination of Microsoft or your favorite open source or ISV to work with within Azure DevOps. So, and to fast track your cloud migration, we have a number of helping hands. So some of those are Azure Site Recovery, originally designed for data or disaster recovery. And now you can use that for near zero downtime migration of services to the cloud. And also for your data sources, you can use Data Migration Service. And that supports minimal downtime migrations of databases, including MySQL, Postgres, and SQL Server to the cloud. So Microsoft has a rich heritage in on-premise environments. And Azure, we believe, is the cloud of choice for hybrid approaches because we have Azure Stack to provide a consistent development and deployment experience. That is running a mini version of Azure in your own data center. And you can also use the built-in scale out to the cloud functionality, which is part of many of our on-premise products like SQL Server. So we also have world-class AI capability to help turn your AI hype, and I'm sure you're all familiar with how much AI hype there is, to try and turn that into reality, permeating your products and making them smarter, as well as saving your company time and money. And the last thing about why we're trusted, we have more regions and more certifications than any other cloud, and identity is the core of our offering. So I believe this means that Azure should be your preferred choice for the enterprise, smoothing your journey to the cloud. Con?
Thanks, Brett. Hello? Can everybody hear me? Good. So I want to do another show of hands. Who is a Cloudera customer? Okay, maybe we're in the wrong room. And who's running workloads in the cloud? Okay, that's good. That's good. So you're in the right room for the Cloudera piece as potential customers. So the first thing, we have a couple of slides here. We have 28 minutes left, so loads of time for questions as well. We have a lot of our enterprise customers who are looking at certain aspects of cloud, right? It isn't all rush to a cloud, a single cloud. In fact, our better use of our name would be hybrid era, not cloud era, in that a lot of our customers, our enterprise customers, still have their on-premise production workloads on-premise, but they have a lot of their development work and their testing in cloud, okay? So you want the ability to run multi-clouds. A lot of our larger banking, telco customers, government customers will choose 2 clouds so they can possibly price match, keep one versus the other. They will look for the same, so if they have an on-premise deployment of Cloudera, they will want the same user experience as they have on-premise in the cloud. So if they're moving their workloads to either transient type workloads or fixed with deployments on cloud, they want the same Cloudera experience when they move that to the cloud. They also want to make sure they're still using open source, so they're not getting locked into proprietary technology. So they're not getting locked into a single vendor, single product solution. Okay, so even if they have they generally have a great experience with Cloudera, but if they don't have a great experience, they still have the option to run Cloudera on Express or just use the open source tooling. Okay? So flexibility is the first one. Second one is manageability. Okay? So they want the ability to run unified data services. They want to make sure they don't have, so for example, if you run with another cloud vendor and you have object store or you have local storage, you might have 4 copies of the same thing. You might be running it on AWS Redshift, or you might be running it on another, as you know, something like a search, or they might have a warehouse, and each one of them have separate siloed data. Maybe they don't use object store. So you want to eliminate data copies, so you don't keep copying data. For example, you might have multi-clouds. You might want one of your warehouses over here. You might want one of your data science workloads over there. Maybe your search goes on a third cloud. So we want to avoid copying data to multi-clouds. We want to have the ability to troubleshoot workloads. So we want to have the tooling that we can look at your cluster. We can predict whether your cluster is in good health. We can give you tips and techniques to make sure that your workload won't just crash. Or you might want to do a rolling update. You might want to update to the latest version of Cloudera, but I want to keep my cluster operational. Okay, so that's what you get from Cloudera. You want to have a shared metadata. So you want to have a catalog of all your data, whether you're doing a Spark workload in the cloud, whether you're doing a SQL workload on premise. You want to make sure you have a shared catalog and also lineage on that workload. So you know who's operating on it, what data they're changing. So that's very important. Shared catalog, shared metadata, both in the cloud, multi-cloud, or on-premise. And security, very important. For our large customers, government, telco, banking, retail, they want the same level of security that they get from their on-premise clusters. So you want the enterprise-grade security. You want the integration with Active Directory, LDAP. You want to have authentication. You want to have role-based access control. You want to have encryption, encryption at rest, encryption with transmission, and you want to have audit and governance on that as well. Okay? So you want your governance. So not just knowing what people are doing on the cluster. Have people signed on to the cluster? Have you had people who shouldn't sign on to the cluster? Are people trying to access data sets they shouldn't? So fully auditable. Any transaction, any access request is fully audited on the cluster, whether that's on cloud or on-premise. And GDPR ready. So you want to make sure that your cluster, if you're running it on cloud, if you're running it on-premise, that it is under GDPR. So you have obviously the right to be forgotten, data subject access requests, so you have security and access on that data as well. So that's what we're seeing with our customers' journey to cloud. And I'd like to say we should be called hybrid era, not just Cloudera. Some of our customers are native cloud. So we have born in the cloud kind of customers who were originally with a single cloud vendor, and that they found that it was very difficult for them to maintain all those different PaaS services, so they went with Cloudera. So they could have a single vendor for doing their data science, their data warehouse, but they could use the infrastructure from a single cloud vendor. And yes, the answer, of course, is Cloudera. So then we'll go into a couple of customers that all run on Azure. So they're joint customers of Cloudera and Microsoft. I know I get my Christmas turkey off M&S and puddings and all sorts of things. And the original use case we had with M&S was incomplete baskets. So shoppers would go and purchase certain items, and some wouldn't do the checkout and pay for their goods. And they wanted to do web analytics on customers that checked out baskets of goods and others that didn't. So they run not only the Sparks loyalty program, so I don't know if you're a Sparks loyalty program, they run 360, they run campaigns, they invite you to wine tastings. They use the power of Cloudera and our data warehouse and data science to do these predictions of customer behavior. The next one is IoT, so Maersk, shipping containers. This is the smart vessel, smart container. And Maersk aren't necessarily the cheapest container company, but they provide the best insight to their customers. So their customers can track where their containers are at any point in time. They feed in tidal data, weather data into Cloudera so they can predict best paths for their ships as they move across the seas. And they provide their customers with a very easy to use analytic 360 so they can see where that vessel is and where those containers are. The next one is Nielsen, data aggregator. Used to have a large warehouse, one of the traditional warehouses, and they wanted to kind of elastically grow their warehouse with more consumer data, and they wanted to grow elastically in the cloud. So that's our advanced analytics, our Cloudera data warehouse. And then the last one is Schiphol. I don't know if you fly through Amsterdam, but the airport in Amsterdam is called Schiphol. And they predict passenger movements. They predict if there's a landing manifest. They know how many customs officers to put on each of the customs so that they know the flow of passengers through the airport. So a lot of very smart. They also are doing something very interesting around drones and whether the type of, they're looking at predicting whether drones will interfere with the flight paths. So some very interesting data science being done by Schiphol and also so it's Cloudera on Azure. So these are kind of the one slide for Cloudera in kind of everything encompassing. So you have from Cloudera modern platform, but a modern platform that does 4 things very well. We do data engineering, so ETL or ELT, you load the data directly into the cluster, then you do your transformations. We provide a all data warehouse, so I'm going to do search, I'm going to do SQL, so I have a full petabyte scale data warehouse. Data science, so now I have a fully loaded data warehouse. I'm going to build some models, do some predictions, so build recommendation engines. If you do your tax here in the UK or in Ireland, you're doing your tax return online on Cloudera. That's the Cloudera backend that does your tax. So then you can deploy it anywhere. That's the beautiful thing about Cloudera. You can deploy it on-premise, you can deploy it private cloud, you can deploy it multi-cloud, the top 3 public clouds. You could deploy it in Oracle Cloud, IBM Cloud. You have different storage options. It isn't all just HDFS. So on cloud, I can use local storage with HDFS. I can get relational type store, updates and deletes at record level using Kudu. That doesn't sit on something. That is its own primary store. And I also work with Object Store. So I work with the Azure Data Lake Store, or I work with S3. So if my data is already in the cloud on ADLS, I can move my workload to that cloud object store. I don't need to there's other vendors we compete against that force you to reload all your data into another object store. If you have your data on ADLS, you can just add Impala or Spark on top of that and get the same experience. You have 2 choices on manageability. We provide Altus managed service, so we can actually manage the cluster and workload for you, or you can do it unmanaged, or self-managed, which is where you spin up the cluster on infrastructure. So we have a PaaS offering called Altus Services, and we have a self-managed option, which is provisioned by Altus Director. And then you get to our secret sauce, SDX, Shared Data Experience. So you want security. You want the same level of security you'd get from a traditional database or a traditional warehouse. You want governance. All the financial regulators, life science regulators, they want it governed. They don't want your laptop data science with people downloading data, doing ETL works and coming out with results. They want governance. They also want to have lifecycle management. How do I know the age of my data? How do I set up rules so I can say after 7 years, I'd actually like to archive and delete that data? And I want a shared data catalog across maybe I have multi-cluster on-premise. Maybe I have multi-cloud. Maybe I have both. But I'd like one shared data catalog for both. So these, I've kind of color-coded this, right? So gray is Cloudera. Red I've called ISVs. You could call them traditional warehouses. And blue is our good friends Microsoft. Okay? So the first use case that we see an awful lot of in the cloud is the Cloudera data warehouse on Azure. Okay? So this is so if you have Netezza, that's end of life next year, you will want to get off Netezza by the end of next year. So you'll want to swap out Netezza. You might want to offload Teradata, offload Oracle Exadata. You might want to do some analytics with mainframe DB2 type data, but you want to do it in an analytic platform that I can do multiple things. So for example, I might want to do search. I might want to search, put all the data in there, both structured, semi-structured, and unstructured data, and run Solar on it. Actually, we have Doug Cutting here today. Doug Cutting invented Lucene. So underneath all those search engines, there is the search engine called Lucene, and that's actually Doug Cutting's wife's name. He invented search. He also invented Apache Hadoop. So I have search as a use case. I can get the same kind of functionality as I would with a Teradata or an Oracle with Kudu. I can do my updates and my deletes. So Hadoop was traditionally schema on read. It was generally append and read. You didn't delete records. You didn't update. And that's why we pioneered Kudu. So you can do updates on records. You can do aggregated scores. Instead of rewriting it, you can do an update directly. So you can do an update and you can do a record level delete. If I want to put image data or if I want to run a customer 360. So if I look at the use cases, I can do structured reporting using Cloudera. I can do my traditional, BI type workloads, my Power BI, my Tableau. We use it ourselves. We use Tableau ourselves on all our data. I can do ad hoc analytics. If I load all my data for the last 10 years, I can do ad hoc, what-if scenarios. Who are my top 10 customers for the last 10 years? I can look at Customer 360. Now, I don't mean just structured data, Customer 360, but I could have video analysis, I could have PDFs, I could have weblog, I could have all that customer interaction stored in a central store and have that available in a Customer 360. Discovery search. I could use the search piece to do search. Maybe I look for a name. Maybe my DPO has asked me, have I deleted all of Paul's data? And I could do a discovery search and check that I have deleted all of Paul's data on my cluster. And I can run big data applications. So if you use Vodafone as a telco, I'm a Vodafone customer, I use the Vodafone app. It's a great little app. If I do, I'm Irish-based, I'm in Dublin, the revenue.ie, when I pay my property tax or do my tax return, that's all, back end is all Cloudera. Same with spend analytics with Santander. That back end of that application is all Cloudera. And we do the streaming. So we stream with Kafka, and we do some Spark streaming as well. We do Spark for CEP, but we also store it here, and then you can run a real-time application on the Cloudera data warehouse. So that's one good example of the kind of workloads we're doing on cloud. And it isn't just SQL. It's search, it's 360, it's all data. It's petabyte scale, it's linearly scalable, and it's cost effective, extremely cost effective. So the next one, the exciting one. Everybody has to have AI, ML, or data science in their literature today. We bought a company called Sense.io 2 years ago. Which was a Jupyter-style notebook, and we Clouderaized that product. It's now called Cloudera Data Science Workbench. We also bought a company last year. I don't know if you know Hilary Mason. Hilary is an incredibly smart data scientist, and she had a company called Fast Forward Labs. They're a applied research organization out of New York. And they're now part of Cloudera's family. So it's called the Cloudera Fast Forward Labs. So there are two companies we purchased to give us more scale and width and credibility in the data science end. So I suppose there's a lot of notebooks out there, Zeppelin, Jupyter, and there's a whole bunch of other companies like DataQ, DataRobot that also sit and work quite nicely on Cloudera. We have a lot of SaaS customers on Cloudera. And they're complementary products. They're folks who've invested in a visualization, drag and drop type data science tooling, or they're SaaS for 20 years and they're quite happy with the SaaS pre-built libraries. This is kind of aimed at data scientists who want to code, people who want to who code in R. They went to university, they love Python, or they love R, they're from the statistics department, and that's what they learned, right? So they want to do OR programming, they want to do Python programming. Now, in a lot of cases, they do laptop data science, right, where they do it on their laptop. They install it, they get data sets, and IT get very kind of worried. You have a whole bunch of customer data on people's laptops with kind of high-end laptops, you know, munging the data and coming up with models. Imagine I gave, I got my data scientists within the bank or the telco onto a governed and secured platform. So I can have, we have in one of our largest customers, GSK, they have 1,100 data scientists using Cloudera Data Science Workbench. And they do that on petabyte scale against data that's stored on our enterprise data hub. And that gives the data scientists the ability to have access to a lot more data. Plus, they have a platform in which they can productionize those models. So they can do their development, they can do their learnings in the development environment, CDSW, they can use the GPUs. We use Dockerization and Kubernetes on the CDSW side. But then when they productionize those models, when they run the execution, we're using those jobs as Spark on Yarn. So they get the power of a 100-node, 1,000-node cluster. They also get access to new data sets. And because we run CDSW on separate edge nodes, they can also develop in isolation. So they can do a pip install of TensorFlow or Shiny or whichever open source library that's cool today or useful today. So they can do their developer isolation, they can work in teams, and they get the power of the platform to do access to data and also the power of the platform to run those models. So you get a hub, you get a data science tooling, you get access to the open source library. So there's nothing proprietary here. This is all open standards. You can then, which is a big worry for data scientists, how do I deploy my models to production? I've done a really cool NLP on customer inquiries. I know how to automate the answers. I can put that into my chatbot on my customer website. How do I move that model into production? And how do I surface a REST API so I can send in a piece of data, which is a customer inquiry, to a bank? You know, I'm in a hell of a lot of debt. I borrowed heavily. Can you help me with an overdraft? How do I automatically write that? Maybe a document back to them, or I write that to the right person within the bank. And how do I provide a REST API interface so I have real-time data coming in so I can fine-tune my model and give answers back? So things like customer churn. So we're doing that. All the telcos, all the banks we have, that's one of their key use cases. Retail banks. Customer churn. How do I do that? How do I build a model? Threat detection. Whether that's cyber, whether it's AML, how do I do threat detection? How do I predict whether I have folks from certain countries trying to attack my organization? Recommendations. I mean, we use this every day of the week. You know, if I go on a retailer website, whether it's M&S, whether it's Sainsbury's, they're using recommendation engine techniques to suggest other products, to suggest value-added products that they can give to their customers. And they use data science models for all of that. Chatbot, another thing that a lot of our algorithms are used for, whether open source algorithms, is how do I automate that NLP? How do I do that natural language processing, separate, take out those noise words, classify it, and how do I do that so that I can automate my chatbot? How do I do predictive maintenance? You know, for example, Dell, Intel have Cloudera. They use it for predictive maintenance on their factory, for making better silicon wafers for chipsets for Intel and manufacturing better boxes for Dell. And then you get into image, facial recognition, quite topical at the moment with Brexit. So how do I do facial recognition, vehicle identity recognition cross borders? And we're also being used for those kind of use cases. So this is the product here, the Data Science Workbench. Experiment faster, work together, deploy with confidence, bring the data scientists to the data, not the data going onto those laptops. Security by default, very important for IT secure ops, run anywhere. And these are the reasons why you should go with Cloudera. So, hybrid era, absolutely. The new norm. Security and governance. Productionize my machine learning AI models. Make it easier to productionize those models. Do it at scale. Have an ability to migrate that model to production. Support the object store. So support Azure Data Lake Store by default, which we do for both Impala and for Spark. Certify other third-party products. So whether it's Informatica, whether it's Qlik, whether it's Microsoft, third-party products and partners who can deliver those projects. And then a wider partner ecosystem. So that was it. And I thought we'd take 2 or 3 questions if you're brave enough and bold enough. Everybody? Does anybody have any questions? We have Microsoft here as well to answer most of them.
Yeah.
Any questions?
Ask something interesting and difficult.
Can you give her the mic?
Thank you. Hi, thank you for your presentation. I was wondering, how do you integrate Kafka with Cloudera? Is it like Cloudera serves as a platform to...
So we ship Kafka as part of our stack. So you don't need to buy separate point vendors who are here today. We ship Kafka 1.0 as part of our stack. You generally run Kafka on the edge nodes, Paul? Or dedicated hardware to do those transactions in. We don't do the Kafka Connect. We use Flume for a lot of the connectivity. We call that Flafka. So you've got the Flume connectors, and then you stream that in through the messaging. We actually have one of our resident geniuses in the audience. Paul, is there anything else you'd want to add to that? Spark streaming integration? Yeah, into Kafka, into the platform.
And there's also a number of Microsoft on the cloud generally. So there's also other Kafka options. You can run IaaS. There's some PaaS offerings as well. So I think there's a number of ways you could do that. And each customer needs to choose their own path for those kind of things. So it's not going to be all right for every customer. Yeah.
Any other questions? So the stand is just there. So if you want to ask us further questions, talk to our resident genius, meet Doug Cutting, the inventor of Apache Hadoop and Lucene, talk to Brett about Microsoft's options on Azure, please do. So thank you very much for your time.
Thanks for coming.